Hello folks, Weasel66 here. Not been around for a while, been a bit busy, but there we go. Anyway, just going to make a little video here about some fake transistors that I have been just checking out, as you will see. Now these two transistors were sent to me by a guy who lives in the Netherlands, who's been trying to repair President Lincoln, and he's not been having a lot of success. Now two transistors we got here. This one is a 2SC1945 made by Mitsubishi, and this one here is a MRF497 supposedly made by Motorola. Of course, the early President Lincoln used the MRF497 transistor, which was discontinued in the late 1990s, along with the MRF497. And of course, in the President Lincoln radio, like the Jackson, they replaced it using the MRF455 in a different package style with a special adapter board in the early mid 2000s. Right, now looking at this 1945 here, it appears to be in the correct package size for an original Mitsubishi. These were discontinued in 2003, like many of the Mitsubishi transistors of this type, 2SC1969, 2SC2166, etc. And it's in the right package size. They did use a slightly smaller package size than most TO220s. This is about 9.5 millimeters in width, originals. If you look at the data sheet, you will see that in the dimensions, and it appears to be just right for a original Mitsubishi. The only thing that I've spotted, which you probably can't see on the camera because it's not quite good enough, is what I have noticed is that the markings on it, the screen printing, is a little bit kind of smudged, and the Mitsubishi logo is a bit not quite right, a little bit wonky. The batch code number there doesn't have a hyphen in it. They're normally hyphenated, but there we are. Apart from that, it much looks right. But when I have a close inspection of the front and get it in the right angle, there are abrasion marks running left to right across the face of the transistor, which indicates to me that whatever was on the transistor has been rubbed off with an abrasive material to remove the original print, and obviously a new number and markings has been badly screen printed back on the front. So what we'll do first is hook up this 2SC1945 to a Atlas DCA55 analyzer and have a look and see what we've got. Right, well, I've got the suspect 2SC1945 connected up to our leads on the Atlas DCA55 just here. It's a bit difficult filming this because obviously I'm trying to do it with one hand. So what we're going to do now is have a look. I'm going to turn on the Atlas and we'll have a scroll through and see exactly what it tells us we've got. Right, let's have a look. It's analysing, and we have an NPN silicon transistor, which is correct, it should be. Let's have a look at what else we've got. Now, according to this, the red is the emitter, which is on pin 3. Which actually, for this transistor, if it is a 2SC1945, is incorrect, because pin 3 should not be the emitter, it should be a collector. It's a common emitter transistor with 2SC1945. The center pin, pin 2, is connected to the fin, and it should be negative, which is the emitter. So we'll carry on scrolling through. We do have diode protection between the C and E pins, collector and emitter, which for an original Mitsubishi part of this type is correct. It should be there. So we'll now scroll through again, and the current gain, we have an HFE of 36, which is a bit low, but it is acceptable. Test current 2.5 mA, and we've got a VBE of 0.79 volt base to emitter. Test current 4.5 mA, and no leakage. If we scroll back there to our pins, what we should actually have is the blue pin connected to pin 1 is actually the base, which according to this is correct, but the positive and negative, which is pin 2 and 3, the emitter and collector, are actually the wrong way round. So straight away this transistor is actually a different transistor which has had the original markings removed, and it's been marked up as a different part. So yes, unfortunately it's a fake. Right, okay, now just for a quick comparison, the transistor I've got hooked up to the leads now is a Elaflow 2SC1945 replacement transistor. Okay, that's what we got hooked up there now, in its distinctive new package style. So let's have a look again and see what we have now. We'll get on to test. Analysing NPN silicon transistor, correct. And now we're on the pin configuration. Red is the collector, which of course is on pin 3, the far pin on the right, which is correct now. And we have the centre pin hooked up on the green there, and that is emitter, negative, on the centre pin connected directly to the fin. So that's correct, it's common emitter. So, and blue, the pin on the left, pin 1 of course, is the base. So now we have the correct pin configuration for this transistor for a 2SC1945. We scroll through. Diode protection between C and E, just like the original. This one has an HFE of 87, which is about midway datasheet spec. Test current 2.5 milliamps, and we got a VBE of 0.69 volt. Test current 4.6 mA, and leakage current of 0. So this transistor is basically exactly spec of what a 2SC1945 should be. Alright, okay, well the next transistor that the guy sent to me to check, which he's also been trying in President Lincoln, is this one. This is an MRF497, which was on the market and used around about the same time as the MRF477. The main difference is that the 497 had a higher frequency spec. It was basically a VHF type transistor, but could still be used in applications around 24 to 30 megs. Had a little bit more gain than the 477, and a lot of people found that when using it they could get a little bit more power. Now, I also know those transistors quite well. I also know that both of them were discontinued in the late 1990s, which is around about the time, early 2000s, when Uniden switched to using the MRF455 in many of their Uniden radios, like the later model Jacksons and the Lincolns. Now, you can't see this too well. The package size is right. Now, it looks about right on the package size. If I turn it over, the fin on the back isn't quite the right shape as I remember, although the package size is about right, and I'll try and get it in a bit more light there. It does sort of have the right kind of markings in about the right places, but interestingly, the first thing I notice a bit odd about it is that the date code on the transistor is R0632, which according to Motorola dating system would indicate year 2006, week 32. Well, that's a bit odd because they discontinued it about 7 years before then, so how can it have a date code from 2006 on it? All very strange. Not quite right, is it? To my keen eye anyway. Some people may not know any different. The pins on it, a little bit thin, not quite substantial as I remember on the original Motorola, but at a first glance it's a pretty good, you know, could be easily taken for the real thing. Now likewise, this transistor should be a common emitter transistor. So in other words, pin 1 is base, pin 2 is connected to the fin and is the emitter, which is negative, and pin 3 should be positive, the collector. So what I'm going to do is hook it up to the Atlas, and we'll check it and see what we have. Right, okay, well we've got it hooked up here on our test leads. Blue on 1, green on 2 and red on 3. So what we should have, if it's exactly what it should be, the blue on 1 should be base, the green on 2 should be emitter, and red on 3 should be the collector. Now, so we'll fire her up, have a look. Okay, well we've got an NPN silicon transistor, which is correct. Unfortunately, what we don't have is the right pin configuration again. The blue base is correct on pin 1. The green connected to the center pin should be the emitter, and it's not, it's reading collector. And the red on pin 3 should be reading in collector, and is actually reading emitter. So again, it is the wrong pin configuration for this transistor. So basically you could install this in such radio as President Lincoln. Let's just turn that on again. And unfortunately, being that the collector and emitter are the wrong way round, probably what's going to happen when you power it up is the transistor is going to go pop and fry itself. But there we are. I'm sure it's happened to many people. So we'll go through. It has a very, very high current gain of 161. Believe you me, I don't think I've ever seen a current gain on a 497 or a 477 that high. But I could be wrong, but I've never seen it that high. Test current 2.5 mA, base emitter VBE 0.67, test current 4.62, and no leakage current. Well, many of these readings you're going to get on these transistors, this could be a voltage regulator, and many of the readings you're going to get are going to be the same. But definitely we've got something wrong with our pin configuration, that is for sure. So if I was testing this before I was installed it, I wouldn't even think about installing it, because I know we're going to end up with a puff of smoke. So unfortunately, there we go. MRF497 fake, and as you've already seen, 2SC1945 fake, although a very good one.